this question is called Boys and Girls. It's two parts. So part A says a company is holding a dinner for working mothers with at least one son. Miss Jackson, a mother with two children, is invited. What is the probability that both children are boys? So a person, like a child, can either be a boy or a girl, right? These are our options, and we're saying she has two children. So each child, so she can have either two boys, like boy boy. She can have boy girl. She can have girl boy, or she can have girl girl, if there was no restrictions. But we're told that we're going to condition this outcome such that she has to have at least one son. Because that's the dinner. That's what the dinner says, right? It's already underlined here. So that means we can eliminate this outcome, the case where it's girl girl, right? So we're saying what's the chance of both being boys out of all the options? So we're saying it's boy boy over boy boy, boy girl, and girl boy. And yeah, so also we say like boy girl or girl boy because there's two ways to have um, opposite genders, right? They can be a boy then a girl or a girl then a boy. Um, right. So now we have this outcome out of the other outcomes, and since they're all equally likely to occur, then we can say it's 1 out of 3. Now, part B says your new colleague, Miss Parker, is known to have two children. If you see her walking with one of her children and that child is a boy, what is the probability that both children are boys? This is a trick question. It wants you to think like how this question was, like conditional probability, we can eliminate outcomes, but we can't. All we know is she has one boy. We don't know anything about the other child. We know that for this case, we know the other child can't be a girl, right? Because we said it's at least one son. We know the other child can't also be a girl. It's all we know. So we can eliminate one outcome. But here we can't. All we know is she has two children and one's a boy. So the chance that the other one's also a boy is 1/2, right? Just how life is. Boy girl is like pretty much equal. So it's like asking your friend that has two children, right? What's one, like child A and child B, and you ask them what's child A's gender, and they say it's a boy. Now child B still has a 1/2 to 1/2 chance of being a boy or a girl. So this is trying to trick you and make you think it's conditional probability when it's not. So you have to know when to apply conditional probability and when not to apply it. Yeah, that's the whole question.